Hello students, today I will be going to solve a problem on Poynting vector. So from electric field intensity expression we will be calculating the magnetic field intensity expression, and then with the help of those two field intensities we will be calculating the Poynting vector. So Poynting vector, you know, is basically E cross H. That means we need to take the cross product of two field intensities to get the Poynting vector. Okay. So Poynting vector I have already discussed in the last session. So you can go back and check what is Poynting's vector and what is Poynting's theorem and what is the significance of that. So before solving the problem, we need to have some concept on time harmonic fields and the phasor forms. So what is time harmonic field? It is basically the field that is periodically or sinusoidally varying with time. And we will be representing that electric field vectors in phasor form, and that phasor form will be it will be convenient to use that phasor form in our analysis or in solving problems. So what is normally a phasor? Phasor is basically a complex number that contains the amplitude and the phase of a sinusoidal oscillation. So let us consider a complex number, say Z. So this is a complex number, so you will have a real part and an imaginary part. So let us say x plus jy. This is the real part, this is the imaginary part. So this is a phasor which will have an amplitude and a phase. So you can represent this in polar form also, that is r angle phi, where you know how to calculate this r? R is basically root over of x square plus y square. Okay, and what is phi? Tan inverse of y by x. Okay, this is r and phi and the relationship between x and y. Or you can represent this z in this form also. So r e to the power j phi. Okay, this can be also a representation, and e to the power j phi, you know that it's basically cos phi plus j sin phi. You can write it that way. So this is basically a phasor which will have an amplitude and a phase. Phi, you consider phase. So this is the phase, this is the amplitude, and you can say this is the phase. So phasor can be represented in rectangular form or in polar form. And for our case, what do we need? We need to study for vectors. So a phasor can be a scalar or a vector. Okay, we are mostly concerned about the vectors here. So suppose we have a vector A, arbitrarily I have chosen. A is basically x, y, z and t. It is a time harmonic field. Time harmonic field means it is varying sinusoidally, periodically with time. Then your phasor form of A will be this I have written. Suppressing the time factor, whatever left is a function of x, y, z. X, y, z means space, 3D space. So it is just only space dependent. The phasor form is space dependent. Okay, and if you see the relationship between this A, this one, and this A's, it is basically this much. A is equal to real part of A's e to the power j omega t. So this e to the power j omega t, this is for time harmonic field. We are assuming that field is sinusoidally varying. So simply just multiplying with e to the power j omega t, it will take the account of the time variation you can account. and AS is basically the phasor form, and you are taking the real part. It is not necessary you need to take the real part. You can take the imaginary part also. Okay, but mostly we choose the real part. So in any book or any reference you see, they will choose the real part. So we are keeping this as real. Okay. So A is basically the relationship is this, and I will show you with an example, a small example, that how can you represent a vector, say, of this form. Suppose you have a vector like this, say A is equal to A naught cos omega t minus, say, beta z. Suppose of this form, and say this is A y. Okay. Suppose. Now, how can you represent this one? See, this is a vector. It is time variant and it is also space variant. It is changing with time and space. Okay. So for this vector, we can rewrite this A in the form what we have seen here. So A will be real part of A0 or A naught e to the power minus j beta z. Okay. And you can give the unit vector multiplied by the e to the power j omega t. This is the time factor. Okay. So I am writing this one like this. So you know that e to the power j phi, we can write it as cos phi plus j sin phi. And your real part for this case is cos phi. So this cos term I am writing as a real, and we are writing this as e to the power j term. Omega t, you can write it in this form, j omega t minus beta z, and you can separate these two out. This is what I have done basically. So this is basically real part of e to the power j omega t minus beta z, and we are separating the exponential terms, and this is what you will get. Okay. Now if you compare this one with this, you will see that what will be the s. So my as will be a naught e to the power minus j beta z a y. So this is my as. So you see there is an amplitude here, there is a phase here. So this is the phasor form. Phasor. This is the phasor form of it. Okay. This is the phasor form. Now, what you can do is, from this equation, again I will be writing this equation, this one. This is just an example I have given you, that how can you write it. This is an example. Okay. Now, this is the main equation, the relationship between A and AS. Now we will see, if I take the time derivative of A, what will you get? So we have A equal to real part of AS e to the power j omega t. This is what we have. Now if I want to calculate this one, del A del t, the time derivative of the field, the vector, what will you get? This j omega term we are differentiating with respect to time, so this j omega term will come out. First of all, you can write the real, and then we have the j omega term, and yes, it is not time dependent, so you can write it as it is, and e to the power j omega term will be. So you see this part, this as e to the power j omega t, This is nothing but this one. Okay. So basically what you can see that del A, del T is equivalent to j omega A's. Okay. So that means what you can say is del D, sorry, this is not AS, this will be A. This will be A. Because this part is nothing but A. And you need to take the real part obviously. So this is equivalent to j omega. So this is what we want to address and this is our focus. So if I take the time derivative, we'll be getting this one. You can take the, you can integrate the vector also and you will get, say, at that time you will get 1 by j omega term. So, but for the time being, means we will be using only the time derivative because we will be using that in the Maxwell equation. So, in the Maxwell equation, you have the this time derivative functions, time varying fields we have, and there we will have the time derivative of the fields. So that is why we are concentrating on this one. Okay. So what we can do is we can, instead of del T, we can write j omega. We can change the, this is basically an equivalence. Okay. And remember one thing, this one, this del, this A, this one is basically your instantaneous form, and this is the phasor form. Remember, instantaneous means it is depending on time. See, it is a time dependent, and it is also real. So this A is basically real, and it is time dependent. Whereas A is time invariant, right? It is not depending on time. So it is A is time invariant, and it is complex, and it is really complex, right? So if you refer to the previous example what you have taken, from here you can see this A is time invariant. This is not depending on time and complex. Whereas this A, you can say this A, it is real and time variant. So why we are concentrating on, means why we are focusing on this phasor form? Because we can generally do the analysis with these phasor forms, and if you want the time variation, simply you need to just multiply it by e to the power j omega t. So e to the power, by multiplying just with an e to the power j omega t, you can you can account the, you can take into account the time variation. Okay, so this is what I want to say. So this is by using the phasor form, it will ease the numerical analysis, okay, or the analysis. So going back to the what we are discussing, that del T will be equivalent to j omega, and we can change the Maxwell's equation, say the third and the fourth equation of Maxwell. What we have, curl of E is equal to minus del B del T. This is what we have, and instead of del T, you can write minus j omega B, and B of course you can write as in like this. This is a flux, magnetic flux density is B, and this is equal to mu H. Okay, this part is equal to mu H. H is the field intensity. So this is the modification we can do in the Maxwell for time varying fields. And another one we have, curl of H is equal to J plus epsilon E del E del T. Epsilon del E del T, permittivity, or you can write in terms of D. D is basically your epsilon E. its electric flux density is equal to the epsilon into the electric field. This you know. So either you can write in terms of D or E. Okay. Now this del del T, here again we have a del del T. So this del del T again we can write change to j omega. So what we have, j plus j omega epsilon E. This is what we can write. That means I have replaced this del del T by j omega. So this is basically your del del T. We have changed. And this both the equations are valid for time varying fields. So this is one adjustment what we have done in the Maxwell's equation. And note that time factor is basically e to the power j omega t. So time factor can be suppressed in our analysis for the time harmonic fields, and we can insert the time factor anytime wherever necessary by simply multiplying with e to the power j omega t. Okay, so this is a background what we need, and then we can solve the problems. Okay, so now let us consider a problem. Then we will see how we can incorporate this concept there. So suppose you have a problem like this: electric field of a uniform plane wave propagating in plus z direction. That means your wave is propagating in the plus z direction. Is given by the electric field is given by E equal to E naught cos omega t minus beta z ax cap plus E naught sin omega t minus beta z ay cap, where E naught is the constant, the amplitude. You are asked to calculate the corresponding magnetic field. That means from the electric field you need to calculate the magnetic field and then the Poynting vector. Poynting vector you can denote it by S. Okay. So how can we solve this? Simply from Maxwell equation what we have? From Maxwell equation what do you know? We know that curl of E, and considering that this is the time harmonic fields, that means the field is sinusoidally varying. So this curl of E will be minus j omega mu h. This is what we have. So we have introduced this j omega term instead of del del t, and B we have replaced by mu h. Okay, this is what we have for Maxwell's equation. Now E is given to us, simply need to take the curl of that E and you can easily find the value of h. So what will be our h? H is basically minus 1 by j omega, right? And then we have j omega mu, and then we have the curl of E. This is what we have. Minus 1 by j omega mu curl of E. This is what you need to calculate to get the value of A. So this is the part A what we are doing now. Part A of this problem. Now minus 1 by j, we can replace this by simply j. How? So see, you know that suppose we have 1 by j. This is equal to j. I hope you know this. Simply multiply the numerator and denominator by j. So we have j and j into j. And what you see, this j into j is nothing but minus 1, root over of minus 1. So j into j will be minus 1. So what we have from here, what we have, minus j divided by minus 1. So that means you will get j. Okay, this you know. Okay, so minus 1 by j I can write it equal to j. And this j term we will see later, we introduce a phase, 90 degree phase, plus 90 degree phase. Okay, so what we can write it basically from here, that j by omega mu equal to curl of. This is what we have. Okay, now you need to take the evaluate the curl of E. Okay, so now let us see. So your H is basically J by omega mu, and then you have the curl of E. So how do you calculate the curl? We need to evaluate a determinant, and this curl of the form is del del x, del del y, del del z, and you have to write the components along all the three directions, and you have to write the unit vectors. So this is the curl of H. This is curl of H. Curl of E. Sorry, curl of E. And remember this E, what they have given is basically in Cartesian coordinate system. So whatever we have applied, it is for Cartesian coordinate system. So if E is in spherical coordinate system, you need to apply the curl formula for spherical coordinate system. If it is in cylindrical coordinate system, then you need to apply the curl formula for the cylindrical system. Okay, note this point. Okay, now tell me, we have Ez. What is the value of Ez? Ez is basically 0. Why 0? Because if you see the problem, this is the problem, do you find any z component? Here we have the x unit vector, that means this is the x component. Here we have the y unit vector, that means it is the y component. So there is no z component here. So your Ez will be basically 0. Okay, and remember one thing, these components are only varying with z. It is not varying with x or y. If you see this Ex, suppose, it is depending on time and z, depending on time and z basically. Ey also depending on z. Okay, so there is no variation in x direction or in x or y. Okay, so now if you take the determinant of this, you will get only this much, j by omega mu, and this will be minus del E y del z, because Ey can vary with respect to z. This is already given in the problem, and x component can also vary with z. Note, there is no vector sign here and here because I have written the components only. Okay, and unit vector is already there. So these are not vectors. Ey and Ex, they are just components and scalar quantity. Okay, and this is what you will get, and wherever you will find this type of term, say Ex, Ey, del x or del y, or del Ex equal to del x, del x, del y. All these terms will be 0 because the components are not varying with respect to x or y. So that means this term, it will definitely come when you evaluate when you will be calculating a determinant. This terms will definitely come and you need to put it 0. Then you will get this one. Okay. Now just simply we need to put the Ex and Ey value and you can calculate the H. Okay, so if we proceed further, so j by omega mu, this I am keeping it as it is. Now minus del del z, what is Ey? Ey given is E naught sine omega t minus beta, and then you have the Ax. This is what you have. Plus del del z, then the Ex component. Ex component is basically E naught cos omega t minus beta z. Okay, and then the unit vector. So this is what you have. You can change the brackets. Okay, now if you differentiate, sorry, this will be z. This will be z. Okay. Now if you differentiate this with respect to z, this with respect to z, what you have? Sine function, if you differentiate, you will get cos. So there will be cos, and it is varying, means we are taking the differentiation with respect to z, so 1 minus beta term will come out. So what we will have? E naught beta, this will come out. J is already there, omega mu, and this will be basically cos omega t minus beta z. This is along ax direction, plus if you take the differentiation of this, so cos, if you differentiation of cos is basically minus sign. So minus, again we have a minus beta here, so minus beta will come out. I have taken this outside already beta, but I haven't taken the minus one. So what you have? This will be sine omega t minus beta z, ay. This is what you have. Okay, so there we have the sine omega t minus beta z, and here we have the cos omega t minus beta z ax. Okay, so remember one thing here, note this point, that differentiating this cos will get a negative sign, and there is a negative here also. So when you take the differentiation, 1 minus beta will come out. So this minus and this minus will make plus. Okay, that is why I have written the plus. There will be no negative sign. So if you do it on your own, you can note this point. Okay. So cos function, if you differentiate, you will get minus sign. So there will be a negative, and from the minus beta, there is another negative. So minus minus, it will be plus. So this is what we have. Just check whether I have done correctly or not. This one. So this is your h, and what you can do further is, since we have a z here, and j is basically, you can write it, it will give to plus 90 degree, a phase difference of 90 degree. So you know, say x plus jy. So here we have only j, right? So x value is 0, y value is 1, and you can say that tan inverse y by x, so y is 1 by 0 tan inverse, and tan inverse 1 by 0 is tan inverse infinity, and this will give 90 degree. Okay, so j is basically giving a phase shift of 90 degree only. The magnitude will be 1. Magnitude you know r, so r will be root over of x square plus y square. X is 0 and y is 1, so it will give only 1. Plus minus 1, I will take the magnitude. So r is basically 1. So r is the magnitude, that means j is not contributing anything on the magnitude. It will give just a phase difference of plus 90 degree. Okay, so what you can do, you can add a plus 90 degree here and also here. Then you can suppress the j factor. Okay, so you can do this. What will you have? E naught beta by omega mu. This you will keeping as it is. Now we have the cos omega t minus beta j. Now we are adding the j, the contribution of j, that is 90 degree, and this is basically your ax cap plus sine omega t minus beta j, again plus 90 degree ay cap. This is the contribution of A. Now this is, you can say, cos theta plus 90 degree, and this is sin theta plus 90 degree, if you consider this to be a theta. So what do you have? E naught B by omega mu cos 90 degree plus theta, cos 90 degree or cos theta plus 90 degree, it will give minus sin theta. So minus sin theta is minus sin omega t minus beta j ax cap, plus sin 90 degree plus theta means cos theta. So cos omega t minus beta j. Here. This is what you have. Okay. So this is basically your h. You have nothing to do further here. So this concludes the party. So answer what? So this is the answer for part A. So E naught beta by omega mu is basically your is multiplied by minus sin omega t minus beta j x cap plus cos omega t minus beta j. Later we will see in our modules you'll see that this beta by omega mu, this is nothing but 1 by eta. Eta means it is the intrinsic impedance. And for air the value is 125 or 377. Later we will see this. Okay. So beta is basically phase constant. We will see that we will see how this beta comes in the next modules. Okay. So this is what we have. Now we need to calculate the Poynting vector, that is part B. How do you calculate the part B? We will simply, now we have the h in our hand. E is already given in the problem, in the question. So what you need to do, you just need to take the cross product of these two and you will get the Poynting vector. Okay. So starting from this, let me take another page. So part B, simply you need to calculate the Poynting vector E cross H. This is what you need to do. You know how to calculate the cross product of two vectors. So cross product of two vectors will be given by, first write the unit vectors, then write the components of E, Ex, Ey, Ez, then write the components of H. And this is what you have. And remember these two, Hz and Hz, they are 0. There is no component of electric field in z direction and no component of magnetic field in z direction. This is quite obvious that I told you that EM is transverse in nature, EM wave is transverse in nature, and electric field and magnetic field will be always perpendicular to each other, and individually they are perpendicular to the propagation of the wave. Okay. So they also are perpendicular to S also, and S direction and the propagation of the wave, that means the direction in which the wave propagates, that is also same. So this S will be along Z direction, along the direction of propagation of the wave, and there will be no components of E and H on that Z axis or along the Z direction. They are perpendicular. They have to be perpendicular to each other. That is why you are taking E cross H. And you know, for two vectors, when you take the cross product, the resultant will be always perpendicular to the individual vectors. So S has to be perpendicular to E and H. And E and H are also perpendicular to each other also. So there are two things. Okay. Now you will see, if you evaluate this determinant, what you will get? You will get Ex Hy minus EY Hx, and the direction will be, as I told you, it will be along a z direction. You can evaluate this one, but just put 0 here, and just simply take the determinant. You will get this. Okay. Now let us put what is Ex. Ex is already given in the problem, so Ex is equal to E naught cos omega t minus beta z. Only I am writing the component, right? And Hy, what is Hy? Hy is E naught beta by omega mu, and we have x component, right? So x component is basically sine minus sine let me check the Hy. Sorry, this is Hy we need to write. This should be Hy. This should be Hy. So for Hy, what we have? Cos omega t minus beta. This is what we have. This is the y part. Okay. Minus, now you have Ey. What is Ey? Ey is E naught cos. Sorry, not cos, sine. It should be sine. E naught sine omega t minus beta z. And what is your Hx? Hx is basically minus E naught by omega mu beta, you can write it here, negative of sine omega t minus beta. This is what we have, and then just simply give the unit vector Az. Okay, so this part is basically your Hx, and this part is basically your Hy. Okay. Now you see, if you multiply this term and this term, you will get, and here also you are getting the same term, E naught beta by omega mu and E naught. So what you have? E naught multiplied by E naught, so E naught square beta by omega mu, and what you have? This term and this term is same. This term and this term, they are same. So we have cos square omega t minus beta z plus sine square omega t minus beta z, and then we have the unit vector. So what you have from here, simply this is basically 1. This is, you know, cos square theta plus sine square theta equal to 1. So this term is 1. So what you have? You have E naught S, this is the unit vector we are calculating, E naught square beta by omega mu Az. This is what you have. Okay. E naught square beta by omega mu and Az. And as I told you, this you can write in terms of intrinsic impedance. So later we will see that this part. This is the unit vector, and this part is basically 1 by eta. Eta is the intrinsic impedance, so it can be written E square, E naught square equal to E by eta. So this is ultimately your Poynting vector, and this is the answer. Okay, for this problem. So those who are, means we haven't studied intrinsic impedance yet, so you can keep it here. Up to this point you can. You need to understand. Omega is the angular frequency, mu is the permeability, beta is basically the phase constant, and E naught square is the amplitude. So this is our problem, and this concludes the problem. What you can do is, you can take it as an assignment that what will be your age for a field like this. Say we have E equal to cos omega t minus beta j ax cap plus 30 sine omega t minus beta j a by cap. What will be your age for this problem? What will be this is, you can take it as an assignment. That means the process is same. Note, remember this amplitude are different. In the earlier case, what we have E naught in both the cases. Here we have, the E naught is same for both the components. Here the amplitude are different for the components. So you can calculate H and then you can calculate S. So you can take it as an assignment and you can show me in the class, or you can WhatsApp me what will be the answer for this one. So basically what we have done, from the electric field expression we have calculated the H with the help of Maxwell's equation, and we are incorporating that time varying field expression of Maxwell equation, and then when you get the S and E and H, you can take the cross product to get the S. And while calculating H, you need to just simply take the curl, you need to evaluate a curl, and when you are evaluating the Poynting vector, you need to just simply calculate a cross product. This is the thing. So I hope the points are clear to you. If you have any doubt, you can contact me, and we will be using this concept what I have discussed here many times. This one. So this is important. So just go through this concept and try to solve problems as much as you can. Okay. So this is all for today. Stay safe, stay healthy. Thank you very much.